Okay, we're going to go ahead and do performing function operations here. And operations on functions. Let's say we have f of x and g of x, and we want to add them. We would write that as f of x plus g of x. It also could be f plus g of x. Okay, like so. We have f plus g of x. The textbook we currently use shows it like this. So that's how I'm going to show it. Really all that means is you're taking f, whatever f is, in this case 4x plus 1, and you're adding to it whatever g is, in this case x plus 5. So 4x plus 1 equals x plus, or plus x plus 5 is a grand total of 5x's plus 5. Okay, that is f plus g of x. Well, my pen is saying win again. I don't know if it's what's going on, but anyway, we'll just kind of try to do our best to ignore that. If we're subtracting, really all we're doing is we're subtracting those pieces. So f minus g of x. So we're taking 4x, and we're subtracting this time x plus 5. Now, note you have to put the x plus 5 in parentheses when you're subtracting because you're dealing with kind of bringing in a negative there. Which really means 4x minus x minus 5, which is 4x, not 4x, excuse me, 3x minus 5. Okay, multiplying, really all you're doing is multiplying the two now. Okay, so we're taking 4x and we are actually multiplying that by x plus 5. Distributive property, 4x times x is equal to 4x squared. And 4x times 5 is equal to 20x. All right, so 4x squared plus 20 there, or 20x there. And then dividing, you guessed it, you just actually divide the two. Okay, so you're taking 4x and you're dividing it by x plus 5. And really, there's nothing you can do with that. That's just 4x over x plus 5. Uh-oh, my battery's running out. Well, I guess that would imply I should actually plug in my computer. There we go. We are all powered up now, ready to roll. Let's go ahead and switch it up here. All right, domains of combined f and g functions must consist of the domains of both f and g, and I'll show you what that means when we kind of go through and evaluate one of these, add one of these up and show you how that affects the domain here. So first, find f plus g of x. State the domain. Okay, so I'm going to take f, which is negative 12 root x, and I am going to add to it g, which is 2 root x. Negative 12 plus 2 root x, well, I'm adding root x's, so I'm going to have something in terms of root x here, and it looks like it's negative 12 plus 2 is negative 10. So negative 10 root x. All right. Now evaluating that, says evaluate the sum when x equals 9. So really that means, and by the way you should write this, I should actually write this out accurately. This is f plus g of x. And that equals negative 12 root x plus 2 root x. And so really I now have f plus g of x equals, let's go ahead and negative 10 root x. And what they want us to do is evaluate that. So here's the first part. Evaluate f plus g of x when x is 9. So really you're finding f plus g of 9. That means you're plugging in the 9 for the, or substituting the 9 in for the x there. So that's negative 10 times root 9, okay, which is also known as negative 10 times 3, or negative 30. Okay, we need to state the domain. Well, the domain, if you think of what a square root function looks like, a square root function, no matter if it's this one, or this one, okay, square root function is going to kind of open to the left or to the right here. In this case, this one is going to start at the origin, and it's it's going to open up to the right or down to the right here, and this one's going to open downward there. Okay. This one, negative 12 root x. Well, if I was to sketch that out, that would also open downward like that, and 2 root x would do something like that. Well, notice when I'm thinking about domain, really what I'm doing is I'm kind of focusing in on the x values. Where does it exist on x? Well, notice on all these, it exists to the right of 0 on x. Okay? So when I make this statement here, domains of combined f and g functions must consist of domains of both f and g. Well, here's the domain of f. Okay? Or here's where it exists, and here's where it exists for g, and it's in the same spot. So really the domain of f says x has to be greater than or equal to 0. And the domain of g is also x has to be greater than or equal to 0. So since they're both the same, really the domain of f plus g of x would also be x has to be greater than or equal to 0. And if we were to actually graph it, we would see it. It looks something like this. Okay, so you could actually start out by doing that, right? I mean, this first one here, subtract the two functions. Okay, we're subtracting them and state the domain. Well, this is a cubic. So when I'm thinking of domain, let's start with that this time. The domain of a cubic, well, a cubic does something like this, right? Now it's going to move around and stuff, the point of inflection, but just a basic x cubed is that, something like that. But notice it keeps extending outward forever, to the right and to the left, keeps going this way and this way forever, which means the domain of the cubic, the domain of f of x, is all real numbers. Okay, and I'm going to write that like that. Well, when I look at this one for g of x, well, g of x now does this, right? Not the best picture ever, but I think we kind of get the point, right? It does something like that. Okay, and once again, it's extending that way forever and that way forever. So the domain of g is also all real numbers. So that would imply that f minus g of x should have a domain should be all real numbers. Now we'll finish it up and we'll see what the picture looks like once we put them together. So let's do f minus g of x. All right, so really what that means we have is f 2x cubed minus 5x squared plus 7 minus g, and I'm putting g in parentheses, right, negative x cubed plus 6x squared minus 4x plus 8. The negative, another way of thinking about that is to add the opposite. So you can make this into plus and then switch all the signs. It's the same thing as distributing a negative. Actually saves a little time. Okay. So by doing that now I have 2x cubes, and then I have a x cubed here, and I'm adding them now. So that's 3x cubes. I have a negative 5x squared, and I have a negative 6x squared. So I have a negative 11x squared. I have no x's here, but I have 4 here, so plus 4x. And then I have this 7 and this minus 8. 7 minus 8, negative 1. Okay? Well, so I have 3x cubed minus 11x squared plus 4x minus 1. That is f minus g of x. That is a cubic. And a cubic, we know, is something like that. So yeah, all real numbers. We're good to go. Okay, the last thing we have to do is evaluate f minus g when x is -2. So substituting -2 in, so 3 times -2 cubed minus 11 times -2 squared plus 4 times -2 minus 1. Okay, well that's -8 times 3, or -24. And 4 times -11 is -44. And 4 times -2, -8, minus 1. That gives me a grand whopping total of, I believe, -77. All right. F minus g of -2 is -77. Okay, so hopefully that helps with domain and range. Let's go ahead and try to multiply some of these, and I won't spend as long on those. But so let's look at the domain of x, or of f. All right, domain of f, think of it this way, it's a quadratic, so the domain is going to be all real numbers. Domain of g, well, the domain of g is a square root function, does something like this. Okay, so looks like this one is x has to be greater than or equal to 0. So you take the more restrictive one. So that would mean the domain of f times g would have to be the more restrictive. X has to be greater than or equal to 0. It couldn't be all real numbers because it doesn't exist over here, right? So we can't use that portion of it. All right, so let's go ahead and test it out and see what we end up getting when we multiply them. So multiplying these out, okay, that's going to be 2x squared. That's f times g, which is square root of x. Well, that's kind of weird to multiply those. Let's go ahead and write x in terms of exponent. Okay, so we could call that 2x squared times x. Square root of x is x to the 1/2 power. Now you have the same base. You have three things you're multiplying here. You have 2x squared and x to the 1/2. So really you have 2 times x to the 2 plus 1/2 power. You have the same base. Same base of x, you add the exponents. Well, 2 is the same thing as 4 halves. So 4 halves and 1/2 is 5 halves. So that's 2 to the, or 2 times x to the 5 halves power. That is what f of g of x is. And that's a square root function raised to the 5th power. Okay, so our domain has to be greater than or equal to 0 because this function is going to, in the long run, is going to be a square root function of a very big number. Okay. All right. What else? Oh, we've got to find f of g, not f of g, fg of 7. So that means 2 times 7 to the 5 halves power, which is, I'm going to use a calculator on that. It's going to be approximately, let's go ahead and round to the nearest tenth here. So approximately 259.3. Okay, that means that when we substitute 7 in for x, we get that out. So the next value of 7 gives us 259.3 on the y-axis. Yowzers. All right, so we've got our domain, we've got our simplified function, and we've got our evaluation. So let's divide them, and then we'll be done with this piece here. Okay, so once again, domain, let's just kind of put some abbreviations here. F, it's a linear, so it's all real numbers. G, the picture is a cubed root, right? Third, the bottom number is what root we're doing. So it's a cubed root, so it does something like this. Also, all real numbers. Therefore, f over g will also be all real numbers. That is going to be our domain. Now we can double check it when we're done, but that should be our domain. Okay. F of g, or f divided by g of x, is equal to 4x over x to the 2/3. All right. So once again, on the numerator we have 4 times x, and in the denominator we have x to the 2/3. I'm going to get this out of the denominator, okay? And so remember, if I want to bring it up, I take the and make it, if it's a positive power, I make it a negative power. So we could write that as 4x, what's already up there, times x to the negative 2/3. Okay, so now we have our x's next to each other. And why that's important is because they're the same base, right? We just have a 4, and the base is x. So when we have the same base, we just add our exponents, and this one has an exponent of 1. So 1 minus 2/3 is negative, or excuse me, 1 minus 2/3 is positive 1/3. So this is, and let's actually write what that is, 1 minus 2/3. Okay, so that gives us 4 times x to the 1/3 power. All right. What is that really? Well, that's a cubed root, right? And so a cubed root, I know it's a cubed root. That's kind of an ugly looking cubed root, but it's a cubed root function, which is all real numbers. We know that because the denominator is 1/3 here. Okay. F divided by g of, we're evaluating for negative 27. That's going to take the 4 times negative 27 to the 1/3 power. That's a cubed root of negative 27. The cubed root of negative 27 is negative 3. And 4 times negative 3 is negative 12. Okay, so if you're struggling with like I just kind of go back and forth between exponent and root. If you're struggling with that, you probably want to go back and review some of the previous lessons in this chapter. Okay, so really our last piece is going to be using graphing calculator technology to evaluate f plus g, f minus g, f times g, and f divided by g when you have a value of x. So I have f of x equals 5x to the 1/3 and g of x equals 16x to the 1/2. I'm actually going to use desmos for this. So open up desmos. Actually, I already have it open, but it'll open it again. Yeah, I did. That's all right. Okay, and what I'm going to do is I'm going to define f. Okay, so f of x is equal to, we have 5x to the 1/3 power. Okay, I'm going to find g of x. G of x is equal to 16x to the 1/2 power. And really from there, all it is, I mean, it's very simple. You just say, okay, well, I want to know what f of 5 is. Well, there's f of 5. And if I add that to g of 5, there it is. So f of 5 plus g of 5 is 44.32. Let's go ahead and just round to the nearest tenth. 44.3. Okay, so I'm just going to write them right below it, and I'm going to do my best to write it without having to close my notebook up here. All right, so f minus g. Let's go ahead and go back. There. That's as simple as going in, changing subtraction. So negative 27.2. Okay, negative 27.2. All right, and f times g. Change it to multiplication. Whoop. There we go. 305.9. And the last one, f divided by g. Yeah, and all you do, go in and put a division sign. Oh, all right. I made it sound so easy. So, now, delete this g of 5. There we go. 0.2. 0.2. All right. Well, there you've got it. I mean, it really is that in a graph or using desmos. Now, if you're using a graphing calculator like TI-83 or 84 graphing calculator, it's a little more complex. You've got to go in to your y equals menu, put those values in, and then go to the VARS button, VARS, and you have an option on there to select the y sub 1 and y sub 2 as one of your VARs. Okay. I'm not going to go through that in this video. I do believe I can give you the steps though, and I probably have shown it in another video. But let me go ahead and pull up my graphing calculator real quick, and I'll hit the steps here. Okay. So sorry about that. Got to switch my tablet around. So in the y equals menu. Okay, so in your y equals, define this one as y sub 1 and y sub 2. Okay, and then if you go to your VARS menu, and then go over to y VARS, so arrow that way, and select y VARS, and then option 1, which is functions. And you want to select y sub 1, which is number 1. So this should have been option 1. And then option 1, y sub 1. Okay, and you'll notice on your screen at that point, what ended up happening on your screen is you ended up getting all of a sudden a y1 appear. And then if you hit plus, minus, multiply, or divide, so whatever operation, so let's say we want to add them. Okay, and then you have to do all of these steps again. You got to go back to VARS. You got to arrow over, you got to select y VARS. You got to select this time option 1 functions. And then you'd select option 2, which is y sub 2. And then on your screen, what you end up having is y1 plus y2. And you hit enter, and you have your answer. Once you have it selected once, then you can just arrow back over and hit subtract or multiply or divide. Okay, I'm not going to go through that actually showing the calculator though. All right, I think that's all I've got. Yep, good lucky.